In this training presentation, we'll be looking at a comparison between a hybrid electric car and the same model but as an internal combustion engine, and look at some of the criteria we use to actually find out what is the best car for us. So the title of this particular presentation is called Hybrid versus Internal Combustion Engine. Let's get stuck into it. So what is the best option when choosing between a full internal combustion engine car or a hybrid? What criteria do you use to actually find the best answer? Or should you go full electric? Now, for this presentation, we're not going to look at the viability of going full electric. We're going to be looking at a hybrid option and an internal combustion engine option. The same model, the only difference being that the hybrid has the addition of a small energy storage component that allows it to actually achieve much better fuel economy. We'll be comparing the overall cost of the two options when it comes to initial purchase price differences, plus the amount of petrol used over a 5 and 10 year period. In addition, we will factor in the purchase price difference and what it looks like if invested into a bank or similar. Now, the approach is going to be that we're going to create a pretty basic spreadsheet that allows us to take the difference price-wise between the hybrid, which is obviously more expensive than the internal combustion engine option, and put that money in the bank and take into consideration the savings with the hybrid from a fuel perspective and a few other things that we'll be looking at. Before we do that, let's look at some key differences between a hybrid car and an internal combustion engine car, and I'll be referring to that as an ICE. Effectively, the key differences are in daily use. You're looking at fuel economy and CO2 production. So hybrids use less fuel and they have a lower tailpipe CO2 per kilometre. Obviously, the internal combustion engine, you're just looking at fuel only, whereas the hybrid, and in this situation, we're actually looking at a hybrid that charges from regenerative braking, not a plug-in hybrid. Maintenance. Now, regenerative braking reduces wear, but the engine will still need servicing. So now we'll be setting up the spreadsheet and we'll go through the process. Now, if you want this spreadsheet, just hit the subscribe button to Greenwood Academy and we'll send you this fully unlocked spreadsheet that we're using in this particular presentation. And remember, don't forget to like, comment and subscribe. Let's get back to it. So the first thing is to open up a spreadsheet, and I'll be using Excel for this particular example. Now, starting in cell B2 and working down the column, type in the following. So deposit, which car comparing to, amount of investment, the interest rate period, the investment term in years, compounding payments per year, number of periods, investment value at the end of the term, and the total interest earned. So they're the headings. We are setting up the compound interest calculator that will take the difference between the hybrid, which is more expensive obviously, and the internal combustion engine, a cheaper option, and the amount becomes the deposit. So just to be clear, in this particular situation, I'm looking at a hybrid model of $39,000, right? And the same model in ICI configuration, internal combustion engine configuration, is $30,000. So we're looking at a $9,000 potential deposit to put into our bank if we go down the road of an internal combustion engine. Now, we're going to leave the calculator part of this spreadsheet for now and instead navigate to cell F11 and input the following headings: price of petrol, the price increase per year, and the kilometres driven per week. So the next bit is purely user input. I've looked at $1.80 per kilometre for petrol, 25% increase per year in the price of petrol, and 1,000 kilometres per week. But we will vary these later on. Now navigate to cell L2 and add the following headings and values. I've included current hybrid petrol consumption figures, but these are all user inputs. So you look at car type, price, litres per 1 kilometre, litres per 100 kilometres, and kilometres driven per week. And the car types are hybrid, hybrid premium, and non-hybrid. And we've got prices of $39,000 for the hybrid. The premium is $48,000 and the non-hybrid is $30,000. And we will just be concentrating on the hybrid and the non-hybrid. The premium is there is just as a bit of a comparison. Obviously, the hybrid premium, you're talking about leather seats, heated seats, all those additional extras, but the fuel consumption between a hybrid premium and a standard hybrid is the same. Have to set up a results table that we can reference, so go to cell P2 and type in the following headings. Now, underneath each column heading is where the formulas of cell references go, except for column P, year heading. In this column, just number 1 to 20. Let's look at the cells under the petrol spent per year hybrid heading. In this case, the amount of $3,650.40 is based on the following formula. J3 is the kilometres that you travel per week. In this case, it's 1,000. H3 is the litres consumed per kilometre. G11 is the price per litre, and at this point it's $1.80. And 52 is the weeks that you're driving per year, so pretty self-explanatory. Let's look at the petrol spend for the hybrids. Both standard and premium consume the same compared to the non-hybrid. And you can see with this table the petrol spent per year for the hybrid and the petrol spent on the non-hybrid and the cumulative spend as well. And you can see as the years go on, because of that increase in of 25% per year, there's a fair degree of difference between the hybrid and the non-hybrid. Remember, this is based on a 25% increase in petrol per year. And as I mentioned earlier, we will look at some other figures later on. Now, the formula for year 2 to 20 is basically as follows. Year 2 takes the figure from year 1, in this case, $3,650.40, and adds the 25% increase. And the formula is as follows. $3,650 plus, in brackets, $3,650 times 25%. So pretty basic maths. But this is not the whole story. Yes, there's savings in petrol, we know that, but the hybrid costs more initially. So if we bought an ICE instead, we could invest the difference in the bank. So this is the thing. It really is a cost-benefit analysis problem. Of course, there's other advantages to buying a hybrid from the perspective of CO2, the sustainability issue, and all of those other things. But in this particular training presentation, I'm looking only at the financial side. We need to see how much money we would have after a certain number of years. So in cell C4, type hybrid, or you could use data validation if you want. In cell C5, type non-hybrid. Cell C6 references the difference between the hybrid and the non-hybrid price, in this case $9,000. C7, user input, and I've picked 4%, so that's the interest rate on my bank account. And the reality is, at this point in time, 4% from the bank is pretty unrealistic. You're probably more likely to getting about 2%, depending on where you're viewing from. But this is where you can vary those inputs. Cell C8, interest rate period relies on the APR and compounding payments per year, which is C7 divided by C10. The investment term in years is totally user input. C11 is number of periods, and this is obtained with a formula C9 times C10. The investment value at the end of term uses the future value function in Excel. Let's look at this more closely. Future value equals the rate, and this refers to the interest rate per period, which is C7 divided by C10. Well, the NPR is a number of periods, and there's 60 of them, and you'll find that in C11. We don't require the PMT. Present value is the initial investment. To get a positive result, input a minus sign first. Total interest earned is the investment value at the end of the term minus the amount of the initial investment. And you can see all the formulas here. Note, I've used an XLOOKUP formula to derive the amount of investment. And you can see the cell references below. Now, we have to ask ourselves a few questions. And the first one is that after 5 years, am I better off buying a hybrid compared to a standard ICE? So let's look at the numbers on the petrol spend. After 5 years, the hybrid has spent a little under 30K, and so has the hybrid premium. But the non-hybrid has spent a little over 61K. So that's a considerable difference. Absolutely no surprises here. Now let's include the purchase of the cars and the petrol spend. So if you include the purchase for the hybrid, you're looking at 68, let's say 69K. The hybrid premium, because it was initially more expensive, you're looking at 78K. And for the non-hybrid, a little over 91K. But we also have to include the interest gained if we pick the ICE instead. So we subtract the interest on the investment. So the hybrid comes down to about 67. The hybrid premium comes down to about 76. And of course, the non-hybrid stays the same because that interest does not apply to it. What if we look at, instead of 5 years, we look at 4 years? So total petrol spend after 4 years, hybrid, 21K, non-hybrid, 43. If we include the purchase of the car, we're looking at 60K for the hybrid and 73 for the non-hybrid. Take away the interest, we're looking at 58 for the hybrid and still 73K for the non-hybrid. So even after 4 years, it's a better deal based on 25% increase in petrol per year, 1,000 kilometres driven per year, and petrol initially at $1.80. So there's a few variables there. 3 years. ICE, the ICE option is better than the hybrid premium option. So non-hybrid 58, premium 60, but the hybrid is still below at 50, a shade under 52K. Now, I've made assumptions concerning purchase price of vehicles, kilometres travelled per year, percentage increase in petrol per year, and fuel economy. We need a way to take these variables into account. I will now be drawing on the what-if analysis function that Excel contains. So here's a question. What kind of fuel efficiency does the ICE need to have to be on equal footing with the hybrid vehicle, including purchase price, after 5 years? Let's have a look. The answer is 4.81 litres per 100 kilometres. Is that realistic? Not really. Let's assume the original fuel consumption for the ICE at 8 litres per 100 kilometres, but look at a smaller percentage increase each year in the price of fuel, say 5%. So what does that do to the numbers? The reality is not very much at all. Okay, we've got 5% increase in petrol per year as opposed to 25%. So what kind of fuel efficiency do we need out of the ICE to get to that same level as the hybrid? And the answer is 5.2 litres per 100 kilometres, which again is totally unrealistic. The last few examples have used what is called goal seek, which allows you to change some parameters to achieve the preferred end result. So we're going to look at how to actually use goal seek. Go to the Data tab, click on What If Analysis, click on the downward arrow, select Goal Seek, select the cell you want to change to the desired value, and you need to change this cell value. Now, a data table is not a standard Excel table, but shows how changing one or two input variables in a formula will affect the formula's output. For example, what if I want to see a range of percentage increases in petrol prices per year and the effect it would have on the price differential? Or what about different car prices? Let's look at different ICE car prices and make the following assumptions. Petrol price initially at $1.80 a litre. Petrol price increase per year, 5%. Kilometres driven per week, 1,000. 5-year investment on the difference between the hybrid and the ICE at 4% compound interest. Let's see what the results are. We're looking at a data table and we're still on 1,000 kilometres per week. So the price of petrol, $1.80, 5% for the price increase per year on petrol, kilometres driven, 1,000. And we're looking at the purchase price now. So I've actually put in a few different purchase prices and you can see how they vary So in other words, instead of 30,000, the original price, you're looking at 29, 28, 27. So a whole range, and see how that actually changes the interest on investment, and you compare it to the existing initial price of the hybrid at 57. The non-hybrid price here is 71. That's at 30,000. And then all these corresponding figures relate to the fact that I can potentially buy the non-hybrid unit a lot cheaper. Now, if I look at 500 kilometres per year, you can see straight away that now I can drop down to $26,000 and below, and it becomes more variable. So you can see now at 500 kilometres per week, if I can purchase an ICE at $26,000, I'm better financially off after 5 years, right? So there's a direct, quite radical correlation. So there's a very radical correlation between the amount of distance you travel per year and the financial viability of this comparison. Now let's look at changing the investment period and the percentage interest rate and see what happens. So now we're looking at 100 kilometres per week, price increase of 10%. The interest rate now is 2% in the bank, and the investment period is 10 years. And the ICE option, straight away, across the board, is the better option. And that's because, well, there's a few things going on there. That's really, but the main one is that we've dropped the kilometres driven per week to 100. Now, if we change that figure to 200 kilometres per week, suddenly you have to drop the price to $24,000 and below to make it viable. Now, if we go to 250, you can see straight away $21,000. Now, you aren't realistically, are you going to be able to buy an ICE at that price? But it just shows you that the amount of kilometres travelled is probably the most major contributing factor to the hybrid vehicle being a more economically viable alternative. So basically, the less kilometres driven, the more viable the ICE option becomes, and this is due to the fact that hybrid vehicles use a heck of a lot less fuel than an ICE, and this is basically the most important factor in conjunction with the comparative price you pay for each of the options. Now, what if we change some other stuff? Let's go back to a 4% interest rate for our investment. We go back to investment term of 5 years, right? We look at 250 kilometres per week, but I've changed the data table variable to concentrate on kilometres driven per week. You can see at 300 or less kilometre mark, ICE becomes the more viable option for a investment term in 5 years at 4%. The question you have to ask yourself really is, if it's purely a financial investment question, how often are you going to be changing your car? Obviously, the longer that you have your car, the greater the difference will be between an ICE and a hybrid vehicle because of that fuel consumption. But also, we haven't looked at maintenance. Maybe maintenance on a hybrid vehicle is higher. In fact, it probably is. But let's get back to it. So if we go to 10 years, you can see the results here. Now, what if we go to an investment term of 2 years at a 5% interest rate? We've still got a price increase of petrol of 1%, but we're only driving 100 kilometres, right? Well, you can see straight away, I can be driving up to 500 kilometres and the ICE is a better option. And that's because the investment term is only 2 years. All other things being equal, the shorter the ownership period, in other words, how many years you actually own the car, the ICE seems to be the winner. Obviously, the more kilometres you drive, the hybrid is the winner. And at a 5-year ownership, and by default a 10-year ownership, hybrid is definitely the winner. It seems that the savings that you obtain from a reduced consumption, if buying a hybrid, makes them the most viable proposition across a range of factors, but you've got to do your own calculations. So if you would like the working spreadsheet that we've used in this presentation, please subscribe to Greenwood Academy and don't forget to comment and like. Or is it like and comment? See you in the next one.